Okay, in example 2, underline something that is often overlooked about L'Hopital's rule. Now here we have some limit that is of the form infinity over infinity. Okay, sine x is stuck between -1 and 1, and x is growing to infinity, so forget the sine x. Both the top and the bottom are going towards infinity. However, if I look at what happens if I were to try L'Hopital's rule, so if I were to try it, I would get 1 here, 1 and cos x. But this limit does not exist. Look, you have this stays as 1, this stays as 1, but this cosine is waving forever. So this limit does not exist. Okay, just because this expression is, waving forever, does not approach anything. Okay, so I cannot use L'Hopital's rule. Okay, L'Hopital's rule, among its stipulations, is that this limit I get must exist. So we can't use L'Hopital. So we have to do something more basic, more elementary. Okay, we'll do this just by dividing top and bottom by x. A technique you may have seen in your first calculus course. Now this sine x over x is going to go to 0. How do I know that? Well, okay, technically I should use something called the squeeze theorem to prove that, since sine is stuck between -1 and 1, and x is growing, this limit is going to be 0. Okay, I'm not going to require you do that in these types of questions, but that's the reason. Okay, sine is bounded. Okay, stuck between -1 and 1. Okay, x is growing to infinity, so you get a relatively small number divided by an increasingly large number. The fraction is approaching 0. So this limit can be done without any fancy footwork. We just get 1 over 1 is 1. Okay, something to watch out for. Okay, when you do L'Hopital's rule, you're looking at the limits of, f prime over g prime. Okay, this must exist. Or the application of L'Hopital's rule is not valid. I'm only sleeping, ba-dum boom boom boom, ba-dum boom boom, keeping an eye on the world going by my window, taking my time, lying there staring at the ceiling, waiting for a sleepy feeling.